The advantages of a low-pressure, continuous flow type of indirect fuel injection system are low operating pressure, good fuel distribution, freedom from icing problems, and the ability to use a pump which does not have to be timed to the operating cycle. Because of the method of operation of the injector, no special idling arrangements are required, and a separate priming system for engine starting is usually unnecessary. The main components in the system are a fuel pump or pumps, a fuel control unit, a fuel manifold or distribution valve, a discharge nozzle for each cylinder, and a throttle valve to control airflow to the engine. A fuel pressure gauge is fitted to enable mixture adjustments to be managed. The system is normally equipped with two fuel pumps which are arranged in parallel. One pump is driven by the engine, and the other is powered by an electric motor. Because of the parallel pump arrangement, fuel under positive pressure from the electrical pump can flow independently of the engine-driven pump. This allows the electrical pump to be used in case of a malfunction of the engine-driven pump and for engine priming and starting. The fuel control unit is mounted on the intake manifold and contains the air throttle assembly and two valves which control the fuel flow to the engine. These are the fuel metering valve or throttle metering valve and the mixture control valve. The air throttle assembly contains the air throttle valve, which is connected to the pilot's throttle lever and controls airflow to the engine. Note that in this type of system, no venturi is required to suck fuel into the airstream. Thus, the chances of encountering icing problems in the inlet manifold are much diminished. The fuel metering valve is mechanically connected to and moves with the throttle valve. It controls the flow of fuel into the engine according to the position of the throttle valve. Thus, fuel flow to the manifold valve and subsequently the injector nozzles is proportional to the airflow. The mixture control valve is connected to the pilot's mixture control lever. By moving the mixture control lever and thus repositioning the mixture control valve, the air-fuel ratio can be varied from the basic setting of the fuel metering valve as required by operating conditions. The mixture control valve can also be closed off completely, stopping the engine and acting as the idle cut-off control. The fuel manifold valve is located on the engine crankcase. It is the central point for distributing metered fuel to the engine. It contains a spring-loaded ball valve. When the engine is stopped, the ball valve is closed and no fuel can flow to the engine. As fuel pressure builds up as a result of engine rotation or booster pump operation, the ball valve opens, allowing fuel to flow to all of the discharge nozzles simultaneously. When the inlet fuel pressure drops below a certain level, for instance at engine shutdown, the spring will push the ball valve closed, shutting off all the fuel to the discharge nozzles. This stops both vapor locks occurring in the delivery line and the engine running on when idle cutoff is selected. A fuel discharge nozzle is located in each cylinder head, with its outlet directed towards the inlet port. Nozzles are calibrated in several ranges and are fitted to individual engines as a set, each nozzle in a set having the same calibration. Normally aspirated engines use a nozzle equipped with a fixed calibrated orifice, which has a series of holes drilled just below the orifice chamber for air entry to a lower chamber. A stainless steel shroud covers this part of the nozzle. As fuel passes through the calibrated orifice to the lower chamber, ambient air is pulled under the shroud and through the screen, finally mixing with the fuel as it is sprayed into the intake port. The fuel injection units used on the engines used in most light aircraft do not need heated air for the purpose of induction venturi icing protection. However, in order to prevent manifold air starvation caused by the filter being blocked with ice, an alternate air system is usually fitted. When a pilot first encounters flight conditions where the inlet filter may become blocked by ice, he should actuate the alternate air door. This will shut off the ram air inlet and, at the same time, admit unfiltered air from inside the cowlings. In a diesel engine, the fuel is injected directly into the combustion chamber. The preferred method of injection is known as the common rail system. The system is designed to constantly supply fuel at high pressure to electronically controlled injectors from a shared fuel reservoir. Shown on the screen here is a very simplified diagram of a common rail fuel injector system. The fuel in the reservoir, or common rail as it is known, is maintained at a very high pressure, approximately 1800 bar or 26,000 psi, by a high-pressure fuel pump. In the cylinder heads, fuel injectors, which are really high-speed solenoid valves, inject precise amounts of fuel into the combustion chamber as required. An electronic, computer-controlled dual-channel unit known as a Full Authority Digital Engine Control, or FADEC, uses information obtained from continuously monitoring the operating conditions of the engine to precisely control the injection timing, rail pressure, and the amount of fuel injected into each cylinder. Common rail direct injection offers distinct environmental advantages. Enhanced combustion efficiency leads to reduced exhaust emissions. The system produces quieter, smoother operation over comparable engines with either direct or indirect fuel injection. That is the end of the lesson. The advantages of a low-pressure, continuous flow type of indirect fuel injection system are being displayed on the screen. Review them before moving on. Here are the main points you need to remember about the low-pressure, continuous flow type of indirect fuel injection system. The system is normally equipped with two fuel pumps which are arranged in parallel. One pump is driven by the engine and the other is powered by an electric motor. The electrical pump is used in case of a malfunction of the engine-driven pump and for engine priming and starting. The fuel metering valve controls the flow of fuel into the engine according to the position of the throttle valve. Thus, fuel flow to the injector nozzles is proportional to airflow. The mixture control valve controls the air-fuel ratio. It can be closed off completely, stopping the engine and acting as the idle cut-off control. The fuel manifold valve is the central point for distributing metered fuel to the engine. A fuel discharge nozzle is located in each cylinder head with its outlet directed towards the inlet port. When you are happy with all these points, move on to review diesel engine fuel injection. In a diesel engine, the fuel is injected directly into the combustion chamber. The preferred method of injection is known as the common rail system. Fuel at high pressure is constantly supplied to electronically controlled injectors from a shared fuel reservoir. The injectors inject precise amounts of fuel into the combustion chamber as required. Injection is controlled by a Full Authority Digital Engine Control, or FADEC. In this lesson, we will look at the fuel injection systems which are used instead of carburetors on some aircraft piston engines. The injection system most usually employed is of the low-pressure, continuous flow type. This system comes in two forms. Some fuel injection systems operate in a similar way to the carburetor by injecting fuel under pressure into the intake close to the throttle valve. However, the most commonly used system is the one highlighted here, where fuel is sprayed continuously into the induction port of each cylinder as close to the inlet valve as possible. and it is this type of system that we will study in this lesson. We will also look at the type of fuel injection systems in use on diesel engines.